Here you go.
This meeting is being recorded.
So you can start with your introduction, Anupama, and we'll continue with our detailed discussion.
Got it. So I basically work for FIS Global right now as an AI/ML engineer, and
Mm-hmm.
the reason that I was hired because they wanted a support system, basically an internal agent, an AI agent that can help solve employees' problems with logging and every other stuff. We do also have another agent with customers that is separate line based, and I do handle that data as well as I built this whole employer agent from scratch. That was the main reason I was hired for. And we've been using Python, Pandas, and SQL mainly for our chatbot. And recently we started using Groovy scripting too to just writing the intent classifications for the chatbot. And I myself have written around 25 plus use cases for this chatbot. And apart from that, as I said, I also handle our data pipelines, which has terabytes of conversational data of our customers, employers, and with our chatbots, both the chatbots. And Snowflake has been our data warehouse from ages. And yeah, I use SQL for query optimization in Snowflake. And apart from this, we also use few AI frameworks like LangChain and QAI. These two have been a great help for us while tool calling and for any API integration within the bot. And before joining FIS, I did my master's from Lawrence Technological University. I graduated from there. And I also got a chance to work as a research focused data scientist under a few of my professors. Here is where I've built my RAG based model, and also a voice based assistant, which basically use LSTM, the long short term memory. And I've also designed a medicine recommendation system, which is called medicine.io, which uses GANs for synthetic image generation, and also uses text to speech. The Google library, basically Google text to speech library for speaking and answering the queries of customers or any person that is using the app. And before that, I started my career as a machine learning engineer intern at HCL Technologies back in India while pursuing my bachelor's. Here is where I got introduced to AWS, and here is where I started working with predictive models and recommendation systems.
Mm-hmm.
And yeah, I'm really looking forward to bring everything, my experience to the team.
Excellent. I
Excellent.
really like the background that you have because this is what I am looking right now. Uh, since you mentioned that with Lawrence Technological University, you were working as a data scientist, and I see you did work as a research focused. Okay, so can you walk me through your transition from data scientist to AI/ML engineer?
Personally speaking, I started, thinking about AI when I was in my second semester. We had an AI, artificial intelligence subject. That is where I got hands on with the chatbots and that project. And I felt myself comfortable there. So I started, learning few online courses and went through my professors for uh, NLP and NLU solutions. And when I deep dived into that, I got to know that can use a few uh, Python libraries like TensorFlow and PyTorch, to work on different projects in AI. So I felt AI is where my career would lie, and it just requires, much more than just training models. It also requires data pipelines and all the infrastructure. So I felt uh, here comfortable.
Okay.
It did.
Okay.
I did
Awesome.
strengthen those areas and while working at Lawrence.
Mm-hmm. And what is driving you to change your employer? I see you are working with Fidelity, and that too, it is a remote project. So, what is making you to change your employer?
Uh, as you mentioned, remote project, I got caught up to one room and it just makes, you know how it is like working from home completely, that one thing. And I've learned a lot at FIS. I'm really grateful for Fidelity. I've learned a lot in many analytics space and also data science space. And now I feel like I'm ready to, showcase everything in a new team. Time to take up a new challenge, I would say.
Mm-hmm. And masters in computer science, data science. Wow, great. Relevant courses, ML computer architecture. That's great. That's great. Hmm. Okay, so you are based out of Charlotte, right?
Yes,
Okay.
I
And
live
are
near the
you
university.
100% sure that you are going to come for in-person interview, because this manager will do just one round and done. So for that
Oh,
he will require you to come on site.
yeah, I don't have a problem. If it's at the Charlotte location, then I think it's like 15 minutes away from me, so I can go. I don't have a problem.
Awesome. Awesome. So, would you mind helping me to understand what is supervised and unsupervised learning?
So basically, supervised learning is something that deals with labeled data, and
Mhm.
unsupervised learning is something that deals with unlabeled data.
So, how would you define labeled and unlabeled data?
Label data is something which is everything is sequenced and everything is in a correct place, while unlabeled data is something you have to work into it, like which is from
Raw
scratch.
data, basically. Okay.
Yeah.
Any example you
It's
have in your
basically,
mind?
um, let's say I have a medicine data which has patient's ID,
No, 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 no.
patient's name.
I think you okay. So what I'm trying to understand is where you will use supervised and unsupervised data. Like any example, any in any application, what kind of application? Maybe you're getting what I'm saying?
You mean the situation where I
Yes,
use
yes, exactly.
supervised and then?
Yes, exactly.
Ah, okay. For training any model or training any bot, I would use supervised learning, which is basically label data, and uh, unsupervised, I would say, for any training purposes, like any documentation or any training purposes, we can use unlabeled data.
Okay.
So, like, I mean, let's say we are in banking sector, right? For
Yeah,
in
that
banking,
you
we
brought
can
this
think
very important topic. So in banking sector, which data you will use? You know,
the
supervised,
data that
unsupervised.
comes. So, let's say I have an example. There is a case where we are doing customer segmentation. So, if the bank has like millions of customers,
Mm-hmm.
we can, for any unsupervised data or unsupervised
Excellent,
learning, we can use
excellent, excellent.
clustering.
Uh,
So,
okay, very nicely articulated. I just loved it. How would you define overfitting, and what is basically overfitting?
overfitting is when a model performs well on training and doesn't perform well on production. Like it learns so much, it learns data too well, that might include any other noise or any random patterns that it learns in the training. But when it sees any new or unseen
Hmm.
data, it would perform
Excellent.
poorly.
Hmm. And how would you define precision, recall, and F1 score? Have you ever used it? And what are these metrics used for?
F1 precision and recall.
Uh-huh.
Sure. So basically, we do have formula for F1 precision and recall. We basically use these to, how do I, like, let's say we are dealing with precision. It's basically with positive and all the negative predictions made by the model. Like we
Mm-hmm.
have the formula here, like true positive plus false positive, and we use this for mainly fraud detection,
Mm-hmm.
basically, and we have recall here, which is actually, like out of all the positive cases, how many did the model find, and yeah, like how many correct predictions that does the model makes. This is what matters in recall. And the formula is, I think, true positive plus false negative, that. And what we left with, we have F1 score, which is basically the mix of precision and recall, we could say that.
Okay. Okay.
Like
Nice.
a
Which
mean
feature
of.
engineering? What are the feature engineering techniques you have used so far?
So at FIS, we use feature engineering only when required, like when the data pipeline has some requirements, certain requirements, we use it, like for any patterns. I've dealt with handling the missing values. That is very common, that
Mm-hmm.
thing. And I think we used mean mode implementation, and also forward filling and also backward filling too.
Mm-hmm.
Uh, Also, we can use that for encoding category, basically encoding category variables, like and I think we use label encoding. Yeah, pretty much.
Okay.
That's
Okay.
it. Yeah.
Which ML algorithms you have implemented so far?
Think I've used few for predictive models and recommendation models.
Mm-hmm.
Yeah. Mm, Supervised and unsupervised is common, and we used I used XGBoost, and uh, yeah, pretty much these. Also, yeah, deep learning techniques.
Okay. Okay. Good. How do you validate a model performance? How do you
That's
how do you validate a model performance?
Uh, so there we kind of follow a protocol while validating a model performance. In that includes like it basically based on the metrics, I would say, like splitting the data, or putting a human evaluation, uh, and yeah, basically these two main features.
Okay. Okay. How do you deploy ML models into production?
So we use AWS,
Okay.
and we've been using SageMaker also.
Mm-hmm.
That one thing. And before deploying, we always, make sure to have like any measurements and observabilities. We also put that as a good guardrail. And we also use frameworks like PyTorch, Skitlearn, and TensorFlow, which is basically like used to train the whole model into any bucket, like S3 bucket in AWS. Then I package the whole model into a Docker container or a Kubernetes container, and then we deploy it through SageMaker.
Okay. Okay. Great. Uh, how would you monitor this deployed models? What tools you have used, or maybe what are the processes that you will use to monitor these deployed models?
So we use dashboards mainly. That's one thing to, showcase our stakeholder how the model is working.
Mm-hmm.
And coming to monitoring, we use also infrastructure monitoring here, because when it is, exposed to different APIs, um, it, it needs to be, monitored through API latency. So yeah, this is one way. And
Okay.
we also,
How do you build have you ever built any kind of ML pipelines?
yeah,
So
I've
how do you do
I've
this?
been yeah. So basically, we have different steps here. First step would be, ingesting the data through sources. We have different sources like APIs or PDFs or any other documentation
Mm-hmm.
that comes, and then data ingestion happens here. Like we use Kafka and Airflow here at FIS, and then it all gets into data storage. Like I mentioned, we have S3 as our buckets and Snowflake as our data warehouse, so we store this in a data storage. And we use pandas and PySpark for also the data processing. Then comes the feature engineering, like we create the feature creations here. Then then model training, where we use TensorFlow mainly here. And yeah, model validation here, which we discussed, the F1 precision and recall comes here.
Okay. Okay.
And
Very nice. I think that's all. That's all. Can you walk me through your LLM project that you have worked so far?
As I said, I was hired for chatbot, right, which uses basically an LLM. So I built the integration from scratch, like discussing the business needs, technical needs, and taking all the requirements to implementing NLP. Then after gathering everything, we had connected it through API. And Yeah, I've also used Cosmos DB for
Very nice. Very nice. Uh,
storage.
yeah, that's it. That's it. Do you know what is why do we do fine tuning and why is fine tuning required?
So, when the model gets hallucinated, we use fine tuning. There are like different techniques for fine tuning.
Mm-hmm.
Basically, it is used to reduce the cost, I would say
Okay.
personally.
Okay.
And there are supervised fine tuning, prompt fine tuning is what I would say the easiest one. You just give prompt to the model, and it understands, and that prevents hallucinations too.
Okay.
Yeah,
So
that one
if you
is.
call fine tuning little costlier, then why people prefer RAG instead of fine tuning?
So, in my personal opinion, RAG is something where there is a vast knowledge. Like it teaches the model right now what to know, what to do. But fine tuning is, it basically tells the model how to behave. I mean, it is low cost, but at the same time, it wouldn't
Okay. Okay. Tell me
work
one
for
thing.
small
Tell me one thing.
models.
If you have a data, if you in your company, there are two types of data. One is static and one is dynamic. Basically, the data keeps changing. Okay. So, which method you
Mhm.
will use, RAG or fine tuning?
I would use RAG when there is, changing knowledge,
Data.
changing data.
Excellent.
I would use RAG.
Excellent. Yeah. Excellent. Excellent. Uh, can you explain the embedding models? Have you ever worked on that?
Yeah. So embedding models are nothing but when the RAG model takes the chunks. The chunks are basically called embeddings.
Mm-hmm.
It stores them in a space. Like let's say there's vector database. It
Mm-hmm.
it stores that in embeddings, and the model basically converts that into text or images or anything, which is basically called semantic. It is semantic, so it's gonna search that by the keyword
Okay.
semantic.
Okay. Okay. How do you reduce hallucination? You were talking about hallucination in the past, so how would you do it?
So there are few ways, like we talked about fine tuning
Mm-hmm.
and implementing RAG, and
Very
also
nice.
always keeping a human in loop.
Mm-hmm. Okay. Okay. How would you evaluate LLM outputs?
Uh, I have two ways here. One is bringing another LLM to judge the initial LLM's output, and
Machine to
also,
machine.
you
Okay.
know, machine, and also, giving a human to, evaluate that. Uh, I mean, they have like different. Uh,
Yeah, you
how
are
would
right.
I put this?
I got your
Yeah,
answer. You are right.
different measurements, basically.
Hmm. Okay. I think that's all what I needed. Probably, let me just stop the recording because this till now it was helpful. I would have some discussion about your joining and all. What is your plan? How do you want to join? Couple of things. So probably that I will stop. Let me just